Okay, question 1.
Where'd we go?
Okay, so I'm just going to pretty much assume I need to do, or at least talk about most of these. What is our MVT?
Mean value theorem.
The secant slope thing.
Okay, so mean value theorem, yes. Secant slope thing. Be a little more specific. Somebody helping us out there.
Isn't that the thing where you continuous
F
is
of B minus
differentiable on
F of
here,
A
so
over
like
B
that
minus A.
value in there works.
Yes, and you might want to move your mic closer or something, Bridget. You do keep cutting out a little bit. But yes, that is correct.
Okay.
So remember, just like with IVT, we had important conditions to satisfy. Same thing goes with MVT. The first one being it has to be continuous and differentiable. So if we look at number 1, cosine is a continuous and differentiable function. Thomas, I can hear myself.
Yes.
Um, I can hear myself talking through your headset or whatever you're using. So be careful. So I have cosine is continuous and differentiable everywhere, so that's fine. ln is a continuous function and differentiable on its domain. So we do have to be careful and always analyze those things. In this case, this ln function is defined everywhere from -1 to infinity. So since I'm in the interval from 1 to 4, it is continuous and differentiable on that interval. We do have to be careful and make sure we state things correctly. We can't just say the function is continuous and differentiable, done, because that's not a true statement. It is not continuous and differentiable everywhere. This function doesn't exist from -1 to negative infinity on the left side there. So there would be no function there, but since we're dealing with 1 to 4, we're okay in this interval. Now, obviously, this is multiple choice, and they're not going to give you a function like this and ask this question if you can't do it, but we do want to be careful. So if we're applying the mean value theorem, as Annabelle was talking about, is we have to look at the secant slope, and we also look at the tangent slope. So first thing is we need to look on the right-hand side and see which one of those tangent slopes is correct, or sorry, secant slopes is correct. And if I notice correctly, all of them are different. Or no, A and B are the same. So most likely it's A or B. So A and B, and then you just need to figure out which value is correct. It can't be F. That would just be the function value is equal to the slope. We don't care about that. So the answer has to be B, I'm assuming, unless it's 0 for this secant slope.
No, it's B.
It is B. Okay. So a couple of things there as we're looking. So F prime of blah equals the secant slope, which is F of B minus F of A over B minus A. So pretty straightforward on what to do there. Hopefully we remember the MVT. Yeah, and you just find the value if you want to use in the calculator. You don't have to use the calculator to find it, because it's obviously the only, unless the secant slope had been 0, which it's not. Okay, number 2. Calculator again. So we know f prime, what's it mean to be decreasing? For a function to be decreasing, what's our definition there?
The slope is negative.
Ooh, that is not a correct statement. You gotta be careful.
That's so sad.
Remember when we talked decreasing, what do we go back to? Which class?
Freak out. I don't know.
Nope. What's everybody's worst thing in calculus?
Algebra 1.
Oh, look at that. We go back to algebra. Decreasing is an algebraic definition. Decreasing means that f of b is less than f of a for b being bigger than a. In other words, as you move to the right, your function is going down. That is the definition of a decreasing function. Now in calculus, we can actually start to take
the same thing as saying the slope is negative.
No, it does not mean the same thing.
How is it
The
different?
fact that the slope is negative tells us the function is decreasing, not the other way around. You have to be careful.
That's whack.
What?
What?
The
What
slope
else is
doesn't
whack?
have to be like
Crack.
negative.
So you have to be careful in understanding there are certain things in certain ways that we have to be careful on which way we have a definition. This goes back to your geometry with the converse and stuff like that, the contrapositives, all those things that you might not have done anymore. I don't know. I think you still do them. But depending on which way you're going, you don't say it's decreasing because the slope is negative. You would say the slope is negative because it's decreasing. There's a difference there. So we do look at the slopes, yes, and the slopes do help us analyze that, but we can't rely on just that. We also need that basic definition of why is this a true statement. So when we look at it, we start talking about, since we have f prime, we can analyze the slopes to help us look and see where it's decreasing.
Wait, I have a question.
Yes.
Okay, so like with the decreasing thing, like for it to be decreasing and the slope not be negative, wouldn't like the rate of change just have to like keep getting smaller? Like at one point it was like
No, it'd still be negative. They go
it
together.
was like 0.5.
They do go together, but the way you say them has to be the correct way. That's the
Okay.
That's the issue. So if it has a negative slope, is it decreasing? Yes, but it's not slope negative. It's the way that it's said. It's a little nuance. Now, will they count you points off for it? Probably not. But you know me.
Yeah, wait, so can it be decreasing without a negative slope though?
No.
Okay.
But the whole definition of slope comes from f of b and f of a, so that's why it has to be decreasing first. Because the definition of decreasing comes before. So, but it's semantics and nuances. So, but yeah, you just look where your derivative's negative. They give you the derivative. It's a graphing calculator question. Just plug that into your graphing calculator and see where that is negative. I don't know what the answer is. I'm not going to even try to plug it in.
Okay, that's what I did, and I got worried that I was like cheating somehow, like that I
No.
wasn't supposed to do that.
No, because they gave you the derivative in this case. Remember, some of these questions are just those basic concept questions. Do you understand this? Is it that? Okay, cool. Great. This was basically just making sure you can make the connection between decreasing and finding where the function's derivative is negative and making sure that you know those two things go together. Hey, Kara, 20 minutes late. Just on time.
It's like normal class.
All right, number 3.
I got this one wrong.
At what time does this? So the first thing, how do we find minimums and maximums?
Plug into your
The derivative.
calculator.
You don't just plug into your calculator because you have the derivative, not the actual function.
Well,
Use the number line thing, right?
Okay, we can use the number line thing, but be a little more specific. How do we use the number line thing?
We
You
evaluate
find
the critical points
the
or something?
zeros.
I don't remember.
So
You have to use second derivative and then find where first derivative is 0.
you don't have to use the second derivative. You can use the second derivative test, so that is a possibility. So you have one of two options. You have first derivative test or you have second derivative test. First derivative test is what Annabelle said, using the number lines. You're basically finding where it's equal to 0 and then seeing where it's positive and negative. In other
Like see where
words,
it changes signs, right?
yes. So where the first derivative changes signs, you have maximums and minimums. Alternatively, you may use the second derivative test, which is not too bad here, and plug in those critical values from the first derivative into the second derivative.
Oh.
And if the first, or if that value is positive or negative, it tells you whether it's a maximum or a minimum. But remember, those are backwards. So for instance, make sure you're paying attention to this. If you plug a 0 from the first derivative into the second derivative and it's negative, that is a maximum. And vice versa. If you plug it in and it's a positive, that is a minimum. You have to remember what second derivative being positive or negative means. That's the concavity and how it's shaped. So whether it's an upwards facing U or downwards facing U. Answer ends up being C, so you find the zeros on the calculator, because it does have a cosine in there, so you're not going to find these by hand. So plug that into your calculator, find the zeros, and then do either first derivative or second derivative test. It's your choice. Does anybody need me to actually fully do out that problem?
I know where I goofed up.
Okay.
I think I just plugged into the calculator and found like the curves, and I was like, oh, there they are.
Yes, no, because they gave you the derivative, not the function. They will never give you the function like that on a calculator question and ask you where it is. Now, could they give you a question with a non-calculator and ask you to take derivatives and set it equal 0, do all that? Yes, but not with the calculator enabled.
Yeah,
They'll
that
never
makes
ask you for
sense.
that. Okay. Next one. Number 4. Let the function be blah on that interval, blah on the following intervals. Okay, so without even looking at 1, 2, and 3, where do I run into issues on this function on number 4?
You have holes.
I don't necessarily have holes.
You have discontinuity at 4, -2.
So discontinuity is a way that we can say that, yes. After we say it's discontinuous, then we can either determine if it's a hole or a vertical asymptote. Clearly nothing cancels here, so they are both vertical asymptotes. You gotta be careful, Annabelle. So none of my intervals can contain 4 or -2. So if they contain those, can't use either of them. And then we also have to check our derivative, so you do need to take a derivative. For the most part, what it looks like. You can automatically throw, I guess they're not making you take the derivative, but you can automatically throw out number 3 because that contains the 0.4 in those intervals. So that's definitely not continuous on 1 to 4. I, to be on the safe side, probably would take a derivative. But even if you take a derivative, you're just squaring the bottom, so you don't really need to take a derivative. It doesn't matter what the numerator would be. So yeah, 1 and 2, because they don't contain 4 or -2 in either of those intervals.
That makes sense.
Yeah, remember MVT rules requires it to be both continuous on the closed interval and differentiable on the open interval. Does that make sense to everybody? Any questions on that one? Okay, number 5. It'd be a differentiable function. Okay, so this is just MVT. So you want to be careful on here, especially since your test will be all free response. What do you have to say before you can use the MVT on this question?
The function is continuous on the interval.
How do you know it's continuous?
Differentiable.
I don't know.
Because
If
it's
it says it.
differentiable.
It does not say it's continuous.
Because
Say that again, Miguel.
Because it's differentiable.
Because the function is differentiable, then it is continuous. So if it's not, if you don't have a way of saying it's continuous, you can't just say it's continuous because the question could be a trick and it might not be continuous. You have to know, is it continuous, yes or no? So this is differentiable, which means it also is continuous. And you should say something along the lines, since f is differentiable, it's continuous. And then you can apply the mean value theorem. Then you're looking for the value, so what f of b would be 11 minus -4 over 10 minus 0, so over 10, so b.
Let's see.
I meant c, sorry.
C. Yeah.
I was looking at b doesn't count because it's that. I was making sure it wasn't 1.5 because it could have simplified down to 1.5 or 0, but I was just trying to make sure it didn't do that. So 15 over 10. Why is it not d? Duh.
Because D is talking about IVT.
Yep, gotta be careful there. I was like not paying attention to the words. I just assumed they all said MVT. D is correct. However, it says the IVT. We don't need the IVT here because we're talking about derivatives. So IVT would not hold. So we were talking about MVT since we're talking about derivatives. And obviously A is out because it's not extreme value theorem, and also because the right-hand side does not equal 0. Okay, number 6. Blah, 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 blah. Do you remember what the extreme value theorem is? Because we don't use that one by name too much, but it does exist.
Yeah, I googled it. I didn't know what it meant.
It really doesn't matter because it tells you to have an absolute max and absolute min. Basically, remember we talked about EVT is basically extreme value, so maxes and mins. EVT just tells you that there has to be a max and a min on a continuous function, basically. So in order to have a max and a min, you can't have things like vertical asymptotes, you can't have jumps, you can't have holes, because they screw everything up. Basically, all your theorems require continuity. Without continuity, everything just flies out the window. So you're basically looking for which one here is continuous. So again, just like the previous problem, we have issues at +1 and -3. So you cannot have +1 nor -3 on any of those intervals, which all of them contain except for C. Does that make sense? And everybody's writing notes to themselves, yes?
Yes.
Yes. Please explain. I guess, but I got it.
Okay, so remember EVT just tells you have maxes and mins, but the criteria for that we talked about, in order to have a max and a min, you have to be a continuous function. Because if you're not a continuous function, you may have a max or a min, but you're not guaranteed to have those things. Just because the way that they work out, it could be really weird, things like that. So in order to guarantee them, we have to have these no jumps, no holes, things like that, especially no vertical asymptotes. Because if you're approaching -1, or sorry, +1 or -3, you're going to either go up to infinity or down to -infinity, and it doesn't matter which one, but that would say that you have no max and no min, because it just keeps going forever. So we can't include either of those values in this case.
Alrighty.
So even if you didn't really know what extreme value theorem was or what was required there, you have to have at +1 and -3 are automatically thrown out. Anything with those intervals, just because they go to asymptotes.
Yeah. I got it.
Let's see, 7, let the function be defined by blah as a domain from 0 to infinity. That's not the function. So EVT requires, and this is a lot of questions to EVT, but the EVT requires a bounded interval. That one you probably missed, to be honest, unless you guessed properly. So even if you did know it, it couldn't have been C because it is continuous on that domain, and couldn't be D. It is differentiable on that domain, but it has to be B. Because it's not a closed bounded interval.
Woohoo! I guessed.
Yeah, so you should have guessed between either A or B, or if you Googled, I don't really care. These are not things that are, like I said, we don't use EVT too much. The fact they have multiple questions on this is kind of weird. I don't find it to be that important. Basically, it just says there's a max if it's continuous and a min. That's all it really says. But it does have to be, like, you can't just go on forever, because that's where you run into, if you go on forever on your domain, then you really never know if there's a max or a min, because it could always be either getting smaller or bigger, and you don't know, and it's weird. Especially with this function, x times sine of x. So if you take the limit, it's going to oscillate, actually, but it's going to keep getting bigger and bigger. So that's why. Which of the following statements could be false? Ooh, these can be tricky. Okay, so we're either using IVT, MVT, or EVT. So IVT, let's see, are we told that it's continuous or anything? Selected values of a continuous function. Ooh, only continuous. So what am I probably not going to be able to use?
MVT.
I most likely probably can't use MVT. So that's my immediate assumption, but let's check just to be sure. IVT from 2 to 5, there's a value, so what does it mean for A? For the IVT to have a value of 10 in between 2 and 5? What would have to happen? Don't all go answer it at once or nothing? For A, the IVT from 2 to 5 to have a value f of c equals 10, what would be required for that to happen?
Okay, I'm confused. Are we on 7?
Like the function would
8?
decrease?
We're on 8, Annabelle. We did 7 already. Why would the function have to decrease for that, Kayla?
Great question.
That is a great question. That's why I asked it.
I mean, I don't know.
Okay, what does the IVT tell us again, people?
It'll guarantee in the interval that there's a value.
Okay, so what would be required to guarantee an interval? On that interval, what would be required to guarantee f of c equals 10?
The function needs to be continuous.
Well, we already have that. Yep, that's the requirement of the IVT itself. But what is the requirement for the second part of that statement? So on the interval from 2 to 5, there's a value f of c that f of c equals 10.
Yeah, why? Well,
Remember, what does the word intermediate basically mean?
middle.
Middle. So that means there's a value of 10 somewhere in the middle. What has to happen to guarantee a value of 10 somewhere in the middle?
Like C has to be greater than 2 but less than 5.
Well, we're not looking for C, but that would be true. That's exactly what that says. So in between 2 and 5, if I need a value of 10. Kayla has a wind tunnel, apparently.
I don't know why, but I do.
So...
Has to be continuous, huh?
Okay, again, you guys don't know how to use your IVT properly. What would you tell me if I said f of c equals 0? IVT.
Let's say you're crazy.
How do you prove something has a 0 using the IVT?
Change of signs.
Okay. What is important about the change of signs?
Oh, one's greater than, one's less than?
There you go.
Yeah, positive and negative value.
So a positive and a negative, which is less than 0 and more than 0 on one side. Doesn't matter which side. Your IVT, we've talked about this. If you guys don't know this, you need to write this down. I talked about this last week or the week before, one or the other. Your IVT tells you that if you have a value below and a value above, every value in between must be had. So in order to have a value of 10, what does one side have to be?
Less than 10.
Or?
Greater than 10.
And then the other side must be? You can just say the opposite.
Vice versa.
Greater than 10.
There you go, vice versa. That works, or however you want to say it. Doesn't matter how. But yes, one side has to be less than or more than, and the other side has to be the opposite of that. So in other words, if I look at f of 2 is less than 10. In order for there to be a value that it reaches 10, what does the other side have to be?
Greater than 10.
Greater than. So one side has to be less than, one side has to be greater than. Does that get accomplished by this function?
Yes.
Yes. One side is 1, one side is 31. 1 is less than 10, 31 is more than 10. That is your IVT. Do not just assume it's used to find zeros. We talked about this. Is it used to find zeros? Yes. We're just changing that 10 value to a 0 value. So IVT has much more uses than just finding zeros. We can't forget that. Remember, IVT tells you it takes on every value in between your starting value and your ending value if it's continuous. So in other words, this function has to take on every value from 1 to 31. No questions asked. MVT, so moving on to part B. By the MVT, well, we can't even use the MVT because we don't know it's differentiable, thank you. Could it apply? Is it possible to apply? Yes, but notice the question. Which of the following statements could be false? We don't know it's differentiable, therefore B most definitely could be false. Now, if you were to do it, do you get all the values that they say there where f prime of c is equal to 10? Yes, you do get that value. Because if I do f of b minus f of a over b minus a, I get 30 over 3. 30 over 3 is 10. They're trying to trick you with b. So the right-hand side does equal 10. However, we cannot use the mean value theorem because it's not differentiable as far as we know. We don't know if it is or not. Okay, extreme value theorem. Is there a value such that f of c is less than f of x? In other words, that's how you say there's a minimum. That's a really funky way of writing out minimum. MD is a maximum. So does there have to be a minimum on this interval? Yes. Does there have to be a maximum on this interval? Yes. They have to be true. So therefore, it is a C and D are true, so B is false. So if you don't recognize what that says, you might want to write f of c less than f of x. That means maximum, or sorry, minimum, and D means maximum. If you want to write that down, up to you. 9. Okay.
Wait, the answer was to 8.
B. You can't use the mean value theorem because you don't know it's
Yeah,
differentiable.
I thought it wasn't B, and I was really confused.
No, it is B. We know C and D are true. Basically, C says there's a minimum, D says there's a maximum. Since it's continuous, those two things have to be true.
Yeah.
Yeah, because that's what EVT is for, maxes and mins. Okay, on number 9, well, we partially talked about this, so in just looking at the answers relatively quickly as I scan through them, C can't be the answer because the second derivative does not tell you increasing or decreasing. So you're going to then take the derivative. This is a non-calculator question. So take your derivative, do your number line analysis, and you figure out apparently the answer is between 1 and 3. Does anybody need me to show that workout for this one?
Nah.
Okay. So pretty easy. So just to double check, you should have gotten, as you do things, your answer should have factored to x minus 1 and x minus 3, which is how you get the 1 and 3, because again, non-calculator question. So pretty easy, straightforward. Okay, number 10. Okay, so again, take a derivative, set it equal to 0, find your answers. This one, probably the algebra is a little harder for you guys, I would assume. Is everybody okay with this one, or do I need to work this one out? No?
Did you say number 10?
Yeah?
Sorry, I was lost the count. Yeah, can you work that out?
Yeah, that's fine. So x ln x. So take your derivative of x ln x. What's required to take the derivative of x ln x?
Product rule.
The product.
Yep. So you have derivative first times the second, so we get ln x plus derivative second times that, so you get x. Like this. So x times 1 over x. So f prime. So you get ln x plus 1. So you set the ln of x plus 1 equal to 0. Notice that the plus 1 is not in the parentheses there or anything like that, so equals 0. So ln of x is equal to negative 1. This is probably where most of you ran into your issues, is solving ln x equals negative 1. So you have one of two options. You can use change of base, et cetera, especially since this is a non-calculator. You can do all kinds of different things. The easiest way is to put e raised to the power of both sides, because we're supposed to know that e to the ln of x is just x, which is equal to e to the negative first, or 1 over e. They're expecting you to know how to do those things with your ln's, which is where most of you probably had some issues. And then you do your number line. So let's see, it's for 0 for evers. So you do your number line at that point for f prime. Start at 0, you get 1 over e, and then it goes forever. So basically just need to check in between 0 and 1 over e what your derivative will be. So what you should realize is that this will be more negative the further left you go, so that'll be negative, and then it'll be positive. So this is all knowing about your graph of ln. Don't forget that your graph of ln x 1 does that. So the closer to 0 you get, or the vertical asymptote really, but in this case 0, the closer to 0 you get, the more negative it goes. So in between 0 and 1 over e, it's going to be more negative. Does that make sense? No?
Yeah. Yeah. Oh, yeah. That does.
Okay. So yeah, it's just knowing your ln functions and stuff like that. 11 should hopefully have been pretty easy. It's a number line analysis. The numbers you should have had on your number should have been 0, 5, and -1. And you could have done this either with the first derivative test or the second derivative test. It is non-calculator, so I would not suggest the second derivative test because taking that second derivative would not have been the easiest thing in the world. So number line analysis is the easy way to go. First derivative test. Do I need to show that out for anybody?
Go ahead.
Nah.
Okay. So what was the last one? X plus 1?
Yes.
Okay, so do your number line for f prime. We get -1, 0, 5. And we're looking for, is it a minimum or maximum?
Maximum.
Max. Okay, so what is required for a max to happen?
It goes from positive.
So positive to negative. So that's what we're looking for. So you just start plugging in values into here and see what you get. So if I pick a super large negative number, that's negative. That's always positive. That's negative. So two negatives makes a positive. If I pick a number in between -1 and 0, that is negative. That is positive. If I pick a number between 0 and 5, they're all positive and positive. So yeah, and because we're multiplying them, you each have to know if it's positive or negative to multiply. So two negatives, an even number actually, so we can do it multiple times, but an even number of negatives makes a positive, an odd number of negatives will make a negative. So this is the only one that has an odd number of negatives. So it's a maximum there. You'd have a minimum there and a nothing there. So your max occurs at -1. Make sense?
I did minimum by accident. That's what happened.
Ooh, and then the dreaded graph question. The graph of f prime, the derivative of f is shown for 0 to 9. Which of the following statements is true? F has one relative minimum and two relative maximums. Relative minimum, one maximum. Okay, so it's basically just asking how many maxes and mins. So what do we have at x equals 1?
Max.
Okay, at 3, someone besides Thomas.
What was the question?
What do we have at x equals 3?
I have a 0.
A minimum.
Why do we have a minimum, Kayla, not a 0?
Because f prime goes from negative to positive.
Correct. Remember, this is the graph of f prime, not f. Jackson, be careful. What happens at 5?
Is it
Another maximum.
Okay, what about 7?
Nothing.
A 0?
So that would be nothing. That's a flat spot where your curve is decreasing, goes flat, and then keeps decreasing. So there's neither a minimum nor a maximum. That's what we call a false extreme value at number 7, because your derivative is 0 there. However, it does not change signs or anything like that. So we call that a false max or min, or a false extreme value. So we had, 2 maxes and 1 min? So A. Yeah, be careful and not to just look at the graph. Don't tell me what 1, 2 max, and 3 min. Is that somewhere? Yep. Don't pick D. Please tell me nobody picked D. I'm going to look right now.
Duh.
Did anybody pick D?
No.
I did, but I was guessing. So
Valeria,
I did.
it's never the easy option, you people. You're killing me.
I
You're
didn't even
killing
see
me.
them like the easy option, but
You're
yeah,
picking how many high points and low points on a graph. Is that going to happen in AP Calculus?
Wait. No, I didn't. I was looking at the wrong one. I did not pick D. I picked B. We're fine.
There were a lot of you that picked D. I'm not going to flame you. You're lucky, but there's a lot of you that picked D for that answer.
Funny.
Are
So
you saying B or D?
D is in dog.
Oh, then yeah, I picked that one.
Yeah, I know. I wasn't going to say anything. I wasn't going to say anything. I was trying to be a little nice.
No, I was confused. I thought you were talking about B. I was like, oh.
Yeah, no D. D is literally just looking at the graph and seeing how many high spots and how many low spots there are. You will not do that in AP Calculus, ever. Okay. All right, any questions on those before we start the next section?
Okay, so if you go from high to low, then that's maximum.
If your derivative goes from positive to negative, that is a maximum, yes.
Okay.
All right, you were supposed to have at least started part B, so there's a few of you that at least started and some of you that finished, so thank you for those of you that did. I will have time to go over a couple. Was that Annabelle?
Yes.
It does not say you opened it.
What? Oh, maybe I didn't.
She's like, I opened it, I did right, and she's like, oh,
Okay,
maybe I
well, I at
didn't.
least thought about opening it.
You thought about it. Okay, that makes it
Yeah.
so much
Progress.
better. You know, because I didn't send out explicit instructions last night to, you know.
Well, I did all 3 of them. I just did bad on every single one of them, so I mean, it's okay.
I didn't think we'd get this far, so I was
OG
hoping I could do it today.
same.
I know would notice.
I quite literally told you guys that we'll finish A and start B, and then on Tuesday we'll finish B and probably finish. The hope was to finish C, which is a possibility.
See,
So-
I forgot about that, so I did all 3 of them, but it was like 11 o'clock, so I did already.
No problem. Okay, so
And I couldn't think.
looks like B is about concavity, so we're going to be taking a lot of second derivatives or be given a lot of second derivatives. So question number 1 is talking about a point of inflection. Who can remind us the definition of a point of inflection?
Where concavity
The concavity goes like changes.
Okay, so none of you gave the really bad answer, which I'm very happy for, the ones you answered. Do not ever say that it's where the second derivative equals 0. That is not a true statement. It very specifically, as people mentioned, has to be where the concavity changes. You will get a lot of false points and false x values here. Sometimes it'll be more than one, sometimes it'll be one specifically, etc., etc. So since they gave me the second derivative, and I have a graphing calculator, what am I going to be looking for on this function?
Where it goes from positive, negative, negative to positive?
Right. So you just graph it and look and see where it crosses the x-axis, because they gave me the second derivative. I don't have to find it or do anything. I just need to graph this and see where it changes. I don't know what the answer is, but yeah. My answer thing doesn't like to pull up. There we go. So apparently it's A. It only does it once. Okay. Let's see. Second derivative of the function is given by blah. Has critical points. Okay, so what does it mean to be a critical point? So we gotta make sure we know what that is. And again, if you don't have these or know these, you should be writing them down somewhere.
Like where it crosses
equals
the
0.
x-axis.
Okay, one person at a time. I vote whoever was talking, not Kayla, I think it was Annabelle.
No, I didn't say anything.
Was it Valeria?
That was me.
Okay.
Yeah.
It was muffled, I couldn't hear. So, Valeria, what were you saying?
That's what a critical point was, right?
Yes, the question is, what is the critical point?
Oh, I said that it was where the first derivative was equal to 0.
Okay, Kayla, is that what you were saying as well?
I was saying where it crosses the x-axis.
You just made a major faux pas in your statement.
Is it because I said it?
It is.
Yeah.
So what is it? What is it?
Your function f prime.
Okay, so where f prime, where the derivative, you said does what?
Crosses the x-axis.
So where the first derivative crosses the x-axis. Okay. Do we all agree with what Valeria and Kayla have said? Because they said the same thing, just slightly differently.
Yes,
No.
we agree.
So Miguel agrees.
I agree.
Annabelle agrees.
Sure.
Kenna doesn't know what's going on and just said sure anyway.
I know what's going on. I just don't know if it's.
Okay. They are both wrong.
What?
What? Oh my god, they're both wrong. They're only partially wrong because they did not include the full definition. Can anybody finish the part of the definition?
Isn't it where it's like the function is like undefined? Maybe not undefined, but something like that.
Careful on what you say. So remember, noting which function you're talking about is very
Well,
important.
f prime.
Where f prime is equal to 0 or undefined.
Oh my gosh, I forgot about that.
Oh my god, it's only like I told you people, this is the one you're going to
Wait,
forget about. Don't
wait,
forget
say it one more
about
time,
it.
slower.
So, yes, don't forget to write this down if you're writing things down, which should be everybody. Critical points happen where the first derivative is either equal to 0 or undefined. Do not leave out your undefined points. So you could have either one of
Can you
those.
repeat that?
Critical points for a function is where the first derivative, or r, where the first derivative is undefined, or sorry, is equal to 0 or undefined. And everybody always remembers the equal 0 part, but forgets the undefined. So very easily we can think about something along the lines of an absolute value graph, the V graphs. Obviously it has a max or a min. A typical one would have a minimum, but the derivative is undefined at that point.
At that point.
Okay. So now that we know what a critical value is, we have the critical points or critical values, and we have the second derivative. How do we determine maxes and mins at that point?
Well, you get the second derivative, you just plug them in.
So we have the second derivative. We must, in this case, use the second derivative test. Remember, we briefly mentioned that earlier. The second derivative test is backwards from what you would think. So when you plug in both 0 and 6.949, you do get negative values. What does it mean that the second derivative is negative?
It's concave down.
So correct. So it is a max, yes, but it is concave down. So since it's concave down, you have to think that means your function looks something like an upwards or upside down facing parabola. So what I just drew up there. So at that point, we're talking about the point at the very top or somewhere in here. Anywhere in here, these are max values. So specifically when I reference that, I always talk about this point right here. So that's the point we're talking about. So that would have a maximum value. That is why the second derivative test is backwards.
Forgot you were on like live, and I've been looking at AP Classroom the whole time, and I can't until you said until like I drew it up there. I kind of forgot you were up there.
You know, because every time I said, "Hey, do you need me to do this one out there?" and they said yes, and I did a whole bunch of work, and you didn't really catch all of it.
I was listening. So you had the problem.
Okay. All right. Okay, so at that point, when you plug them both in, you get negatives. I'm looking at the answer, so that's the only reason of that. So just plug them both in. You have a calculator. You can plug in 0 and 6.949. This is the one case where they gave you a function, they gave you an x, you get to plug it right into it. Doesn't happen very often, but you just plug into that. You just have to be able to read the results of being positive versus negative. So just be careful with that. Don't forget those. All right, 3. So how do you, I mean, you could really use either one of these, the first derivative test or second derivative test. You have to be very careful though if we're checking for absolute max and absolute min. Does anybody remember the thing I told you to check for that you'll probably forget?
Endpoint?
Very good, Miss Kaylee. Your endpoints. Don't forget to check your endpoints. Because she Googles.
Yep.
So yes, do not forget your endpoints when checking for absolute max and absolute min. You must plug in both the critical values and the endpoints. In this case, the max actually happens at the endpoint of 1. So you do have to be very careful there. If you don't remember to check your endpoints, you will get an incorrect answer. So check any critical values and the endpoints. Number 4. Excuse me. Number 4 is the same question, or same type of question, but you have derivatives of sine and cosine. So this is where you have to be able to figure out where it's equal to 0 and stuff like that. So most of you probably made a couple mistakes on setting your first derivative equal to 0 if you've done this one. It's not too bad, but most of you probably made mistakes on that part. Does it happen at one of the endpoints? Ooh, the answer does not happen at one of the endpoints. So you do have to solve your first derivative correctly. Anybody need me to show anything out on number 4 that has done this problem?
Sure.
Can you?
Yeah. So when you take your derivative, everybody should be able to get the derivative part right. So you should get cosine x minus sine x. Now the hard part being for most of you, when you set this equal to 0. And again, a couple of things as you note. Notice how I did not in that first line say f prime of x equals sine x, or cosine x minus sine x equals 0. You take a whole new line to make it equal to 0. Otherwise, you're telling me the first derivative is equal to 0, and that's a false statement. So how do I get an answer when I say cosine x minus sine x equals 0? Anybody have any suggestions?
45.
Okay, that's not a suggestion. That's an answer.
Don't we move it over to the other side and...
Okay, so move whatever to the other side, Thomas.
The sine x?
Okay, you can move the sine x over. That's one option. So you get cosine x equals sine x. And then what do I do?
Aren't there like trig functions or something?
Well, cosine x and sine x is a trig function. Yes, that is correct.
Well, okay, but don't you have to use like...
I believe the word you're looking for is an identity, maybe?
Maybe.
Like where you switch things in and out?
Yeah.
Yeah, that's an identity. And no, we don't necessarily need one here. Can you use one? Yes. Do you have to use one? No. Okay, you should just know the answer at this point.
45.
Okay, elaborate on that, and also why is that wrong?
I'm supposed to elaborate why it's wrong?
They're supposed to elaborate on how you got 45, and then also explain why it's wrong, though. Because you're partially correct.
Okay, I'm guessing I'm wrong because it's better to use radians, so that would be pi over 4.
Okay, that is the correct part. And it's not better to use radians, it's required to use radians.
Okay, and it's correct because it's square root of 2 in both cases, over 2.
So you're looking for where sine x and cosine x have the same value, and you should know if you're doing degrees, he's correct, 45 degrees. However, all of calculus must be in radians as we do it. So pi over 4. That is one way of doing it. You should know that answer. However, you're also missing another answer. This is where you've got to be careful. You're also missing the third quadrant angle of pi over 4. The better way
Okay.
to do this, as you're doing things, for those of you who don't remember everything, I would divide by cosine of x and get 1 is equal to, what is sine x over cosine x?
Tangent?
Tangent.
As tangent of x. So for most of you, it'll be easier if you say, okay, where's tangent of x equal to 1? And you should hopefully know that's 45 degrees as well, or pi over 4. However, just don't forget to check your domain. Our domain in this case is from 0 to 2 pi. Do we have brackets on those?
See, I wanted to divide by cosine, but I didn't know where to go after that, so I didn't say it.
You're fine. So you get, our domain is from 0 to 2 pi, so we got to make one full circle around. So tangent, remember your ASTC, tangent is positive in both the first and third quadrant. So you're going to have 2 answers. So obviously we got pi over 4. Does anybody remember the third quadrant angle, or how to get the third quadrant angle? That is pi over 4.
You add pi.
It's pi or 5 pi over 4.
Okay, very good. Both of you are correct. So you add the pi, so you gotta go here and then down a little more. So it's pi plus the pi over 4. So your answers here are going to be pi over 4 and 5 pi over 4. You can't forget the extra quadrant angles that you need. So always gotta check your domain to see where you start and stop. And then at that point, you plug the pi over 4, 5 pi over 4, 0, and 2 pi into your trig functions, which I'm going to hope that everybody remembers those values.
Sure.
So if you don't remember those values, you just have a chart of your trig values. I don't know if they're going to rear their head this year, just because how the test is going to go, but you never know. So you should probably at least have a chart of your trig values written down somewhere. Okay. Any other questions on that problem?